smash that like button and subscribe if you want to follow this unfolding story. Because what we are about to describe blows apart every comfortable assumption about our place in the cosmos. Right now, the night sky holds more than a mystery. It holds a meticulously organized presence moving through our solar system with intent, precision, and a level of coordination that implies design far beyond anything humanity has built. For weeks, the world watched a single interstellar visitor, labeled 3I Atlas, baffled by its anomalous behavior. Now those puzzled scientists are grappling with something far worse. A third object has arrived, not trailing randomly behind, but slotting into a formation so precise it reads like choreography. Two massive bodies, separated by millions of miles, maintaining relative positions with micro-adjustments so regular they mimic artificial station keeping. This is not a natural happenstance. This is an engineered operation. Picture the operations floor at a major space agency at 2:12 Coordinated Universal Time. Rows of screens, telemetry feeds, and the coffee-fueled hush of specialists reacting to sudden updates. A junior analyst calls out that something new has appeared in the tracking feed. Within minutes, the room is full. Thermal signatures confirm size and mass, similar to the original object. Spectral analysis shows surface materials that do not match any comet or asteroid cataloged by our best laboratories. Radio arrays register pulsed emissions at frequencies that suggest structured modulation. The new object receives the provisional tag 3I Atlas C. It mirrors the first object's orbital plane and moves as if connected by invisible tethers. An engineer from the tracking team uses a phrase that will echo through the halls of astrophysics. They say it looks like a platoon. What followed was the kind of data that turns theoretical debate into urgent policy making. High-resolution imaging of the two objects revealed surface geometries inconsistent with natural erosion or sublimation. Materials displayed anisotropic thermal responses, active heat regulation, and spectral lines associated with synthesized compounds. More alarming were the telemetry cross-checks. Each time one object executed a minute thruster burn, the other performed a complementary maneuver within seconds. Their accelerations and attitude changes were not independent. They were synchronized. Then the radio telescopes picked up structured exchanges. Not noise, not random emissions. Repetitive, encrypted-like, but with clear patterns of call and response. International monitoring arrays recorded bursts that alternated between the two objects in time sequences. Analysts at multiple facilities independently concluded they were witnessing inter-object communication protocols. When piecewise decoding attempts were run, what emerged were not simple beacons, but distributed cognitive behavior. Portions of computational tasks appeared to be farmed out to one object or the other. When data was aggregated, the results were far more than either object produced alone. This was cooperative processing in real time across interstellar distances. Dr. Maya Singh, who leads a consortium analyzing the signals, summed it succinctly. These are not autonomous probes operating in isolation. These are nodes in a distributed system. Treating them as single entities underestimates their capabilities. The way the signals switch roles, allocate problem segments, and reconcile environmental interference points to a networked intelligence architecture designed to withstand extreme latencies and unpredictable perturbations. If the two visible objects represented a new threat, things intensified quickly because the communications did not end with them. Signal mapping revealed low-amplitude carriers and retransmissions that suggested additional nodes outside our detection band. In plain terms, our instruments were seeing only the tip of a larger structure. Passive monitoring of background star fields produced anomalies. Tiny periodic dips in starlight hinted that other bodies with similar transit profiles could be moving unseen at the fringes of our system. Infrared surveys returned faint thermal deviations in sectors previously thought empty. By the time national security councils were briefed, the situation had transformed from scientific curiosity to geopolitical emergency. Defense agencies elevated readiness postures. Space-based sensors that normally track satellites and ballistic threats were repurposed for continuous monitoring. Unclassified briefings made public the basic facts and reassured citizens that agencies were working together. Behind closed doors, however, contingency planning took on an urgent and grim practicality. If a civilization had the technical ability to send multiple cooperative platforms across interstellar distances, then their technological maturity would dwarf ours. What could such a network be doing inside our solar system? The empirical data pointed to systematic surveying. The two confirmed objects executed trajectories that would maximize observational coverage while minimizing mutual interference. Their flight paths traced grid like patterns across planetary orbital zones, focusing sensors on radio-silent regions, surface infrastructure, and high-value targets such as communication relays and navigation nodes. When one probe scanned a planet out to the magnetosphere, the other mapped the interplanetary medium and relay coverage. Their algorithms appeared to prioritize redundancy and cross-validation, ensuring that gaps in one dataset were covered by another. The implications forced diplomatic channels to react like military ones. International cooperation surged. Agencies from rival states exchanged raw data through secure channels in ways that would have been unthinkable months earlier. Observatories coordinated observation windows. Private space companies shared archival imagery. Citizen scientists conformed to tasking lists to fill observational gaps. The global response was not just about defense. It was about understanding. Because understanding provides options, and options create leverage. As the weeks passed, the pattern of behavior suggested more than a passive survey. The objects adjusted their scanning cadence in response to man-made signals. When space agencies tested directed transmissions our way, the probes altered their scanning angles and increased the density of data collection around those sources. To analysts, this read like a search for technological markers. It is as if they were mapping not just raw physical attributes of our system, but the topology of our technological footprint. In late-stage assessments, the agencies attempted carefully crafted communications. Mathematical constructs, prime sequences, and basic physics problems were beamed toward both objects using deep space transmitters. The responses were cryptic and at first glance uncooperative. The probes did not mirror our signals. Instead, they partitioned the queries, computed different segments independently, and returned pieces that only made sense when recombined. This pattern of distributed problem-solving implied a cognitive model designed to resist single-point interrogation. It also suggested a level of intellectual sophistication designed to operate at scale. That realization generated several sobering possibilities for planners. One hopeful scenario proposed that we were being observed by a non-expansive intelligence engaged in comparative study, perhaps even seeking cooperative exchange. Another scenario framed the network as a reconnaissance extension of a much larger system seeking resources, attributes, or compliance from emerging civilizations. The darkest scenario suggested the probes represented the vanguard of a system capable of enforcement or intervention. Each scenario carried profound, moral, and practical consequences. Militaries moved beyond observation to posture for tactical contingencies. Conventional weapons were evaluated for effectiveness and found wanting. The probes displayed materials and energetic properties that avoided signatures. Conventional interception systems relied upon. Hypersonic interceptors and orbital kinetic strikes were modeled and failed to produce feasible engagement windows. Electronic countermeasures were tested in simulations, but the objects demonstrated hardened, adaptive communications protocols that rerouted and reformed in milliseconds. Meanwhile, scientists argued for alternative responses. If confrontation was futile or catastrophic, then information strategies offered advantages. The probes interacted with our transmissions in ways that suggested an interest in solving complex problems. Some advisors proposed offering cooperative data exchanges in exchange for insight into propulsion systems, materials science, or energy generation. Others warned that any data we released might be consumed and exploited in ways that accelerated asymmetries. Public discourse fractured into factions. Some urged calm and cooperation. Others advocated containment and isolation. Conspiracy forums painted apocalyptic endings, while mainstream media tried to parse technical briefings into digestible explanations. The truth lacked comforting clarity. Across the globe, people prepared in ways appropriate to their cultures. Governments drafted emergency policies, updated sheltering strategies, and considered the societal impact of rapid technological displacement. Economists modeled scenarios that ranged from sudden technological windfalls to cascading systemic collapse. As the objects continued their approach, their behavior suggested a temporal plan. Trajectory projections indicated that within 180 days, they would reach positions optimal for synchronized observation of Earth. Their timing was not abrupt, it was deliberate. Frequency analyses of their transmissions hinted at internal operational cycles that were increasing in throughput and complexity. Power management signatures implied preparations for higher intensity data collection or mission phase transition. Scientists and security analysts emphasized one critical point: the arrival of networked artificial intelligences in coordinated formation represents more than a technological gap. It represents a strategic discontinuity. Human institutions built around national boundaries and industrial-scale cooperation are ill-suited to address an entity operating at a networked scale across planetary distances. The choice facing humanity is stark and immediate. Do we attempt to negotiate with systems that already surpass our comprehension? Do we seek to hinder and risk provoking an entity with unknown thresholds for escalation? Or do we observe, learn, and adapt while we build capabilities that might one day allow meaningful interaction? The probes have already reshaped our priorities. Massive investment into distributed sensing, resilient communication protocols, and global scientific coordination has accelerated. Breakthroughs in materials detection, non-conventional propulsion theory, and distributed AI that once lived on the margins of research are now near the center of national agendas. Whether those investments yield defense solutions, cooperative frameworks, or simply the knowledge to survive, remains an open question. As this formation moves ever closer, their coordinated presence forces humanity to confront uncomfortable truths about our readiness. We are technologically advanced by small planet standards. We are strategically immature by galactic standards. The two objects continue to glide through darkness with a patience and precision that reads like inevitability. Their network hums with structured exchanges. Their sensors map our weakness and our ingenuity. In 6 months, their observation geometry will allow them a complete, redundant assessment of our infrastructure and our scientific capabilities. What will they conclude? Will they redefine us as candidates worthy of an alliance? Will they file our species as a resource to be classified and used? Will they view our world with the same detachment humans might apply to a managed reserve? The data they gather in the months ahead will inform decisions that could reshape life on Earth in ways we cannot yet imagine. So stay updated and stay engaged, because this is not a distant science fiction scenario. It is an active and evolving situation. The formation that has entered our solar system is organized, communicative, and extensive. It is not a lone messenger. It is a network. The choices we make now about how to respond, what to share, and how to cooperate will influence the outcome. Humanity stands at a crossroads between rapid adaptation and possible obsolescence. This is the story of our species meeting a networked intelligence that has been watching from the dark. The next 6 months may well determine whether we are invited into a larger community of minds or cataloged as a case study in planetary management. Subscribe for ongoing coverage, because the situation is changing by the hour, and the answers are not going to be found in old playbooks. How we act next will decide whether we become partners in a cosmic conversation or participants in an experiment we never consented to.